So we saw how to restrict the sine function and restrict its domain so that we could have a one-to-one function and then draw the inverse function to get inverse sine or arc sine of x. Now we're going to talk about the cosine function, and we're switching over to the whiteboard here for this one. And so, like the sine function, I still want to restrict the domain of my cosine function. So I've got a picture of the cosine function drawn, and the way that the portion of the cosine function that we are going to be looking at is the portion that starts at the top of the hill and drops down until we hit the bottom of the hill, or the bottom of the valley, I should say. So the portion of the cosine that we are looking at is the portion for x values from 0 to pi. So our domain, or I should say our restricted domain, is x values from 0 to pi, and our range, well, the range still is all the y values because we have y values up to y equals 1 and y values down to y equals -1. So our range is -1 to +1. Now you might be thinking, well, Diane, why don't we just use the same restricted domain as we had for the sine function? And that would mean that we would start at -pi/2 and go to pi/2. And the thing about that is that if we choose that same portion of the graph, then our function is not one-to-one, and so we're not going to be able to have an inverse. So we have to choose a different restricted domain for the cosine function than we did for the sine function. All right, now as far as those choices go, these are not choices that we make and then we just make a different choice next time. These are choices that have kind of been formalized, and everybody agrees that these are the restricted domains that we're going to use. So you want to get to know the restricted domain and the range for the portion of the cosine function, the portion of the sine function, and the portion of the tangent function that will be turned into the inverse function. Okay, so now that we have this portion of our graph, you might try envisioning what it looks like to draw that y equals x diagonal line. And see if you can envision what the reflection of that green portion of the graph will look like to look at our inverse cosine function. Now for me, it's really hard to try and envision graphically what that graph is going to look like when I reflect across the diagonal line y equals x. So instead what I'm going to do is I'm going to help myself by plotting some of these points. Now, remember that when we find the inverse function, the x's and y's are swapping places. And so places where I had an xy on the original cosine function will now become a yx. So let's look at some important points. One of the important points is our starting point, which it has an x value of 0 and a y value of 1. That point, when I draw the inverse graph, is going to swap the x's and y's, so we'll have the point 1, 0. So here is the point 1, 0 on what will become y equals inverse cosine of x, or y equals arc cosine of x. All right, so there is one of our points. The next important point on our original cosine function is the point pi/2, 0. So when we flip-flop the x and y for our inverse graph, we have 0, pi/2. All right, so here is pi/2 on the y-axis, and here is our point 0, pi/2. And our last point is the other end point of our restricted portion of the cosine function, and that point is the point pi, -1. And when we flip-flop the x and the y, we have the point -1 comma, pi. Okay, so now I have these 3 points on my inverse cosine graph, and I'm going to go ahead and draw the rest of the picture. You should convince yourself that this picture should look something like this. Should be kind of going left to right, kind of steep, goes kind of diagonal through that center point, and then gets real steep at the end as well. So places on the original function that were kind of flat are now places on the inverse function that are rather steep. Okay, so now we have a picture of our inverse cosine function. You want to get really comfortable with that graph. You want to know what it looks like. You want to be able to draw it on your own. Now, here are some of the properties of this inverse cosine graph. So, like with our inverse sine function, the domain and the range are swapping roles, just like x's and y's swap roles or input and output swap roles. So, the domain for inverse cosine or arc cosine, the domain is -1 to +1, and this makes sense. Those are our x values, the values along our x-axis. And our range was the original, the domain of the original function, and so the range is 0 to pi. So we took our domain from our original and made it into our range. We took our range from our original and made it into our domain for our inverse function. Okay, that last guy there should be a square bracket, not a round bracket, because we want to include the endpoints. Okay, so that's our domain and range. The other important properties or other important observations about this function are that the input into this function is a ratio of sides. In particular, the adjacent side over the hypotenuse side, or if you are looking at an angle in the xy plane, you're thinking of x over r. And the output is an angle. And because our range is 0 to pi, because that range there is 0 to pi, the only angles that we are allowed to choose are angles from an angle of 0 to an angle of pi. So we can only choose angles that are within this top half of the xy plane. Okay, so we only get angles in quadrant 1 and quadrant 2. Okay, so this is our inverse cosine function or our arc cosine function. I want to emphasize that this picture that we have up here, this picture of our inverse cosine function, that's it. It's not like this graph continues off to infinity or anything like that. That is it. So let's graph the inverse cosine or arc cosine function on our graphing calculator. So what I have here is a screenshot of the TI-84, and we're going to graph the inverse cosine function. And I'm going to start by graphing this using Zoom Standard. Again, that will give us our -10 to 10 in the x direction, -10 to 10 in the y direction. And after I hit enter, then the picture I get is this little guy right there, and that's it. That's right. This is the entire arc cosine function. There's no more. You can search large x values, small x values, large y values, small y values. The entire graph is that little itty bitty piece right there. Alright, so it might make sense to zoom in on this, and so some values that might make sense, since our domain for arc cosine is -1 to 1, then our x minimum will be -1 and our x maximum will be +1. And then for our y values, since our domain, I don't mean domain, since our range, if I'm talking about the inverse cosine function, we're talking about the range being 0 to pi, So my y values, my y minimum will be 0, and my y maximum will be pi. And I've chosen an x scale of pi over 2 just because I know that our arc cosine function crosses the y-axis at pi over 2, so it would be nice to have a hash mark at that point. Okay, so once I've chosen all these values in the window, then I can move on and graph the function. And here's the picture I get, and this looks pretty close to the one that we drew earlier on in this part of our lecture. Okay, so just like with the arc sine function, for the arc cosine function, you want to remember the shape of the graph, you want to remember the domain and the range, and you want to remember that the input into the arc cosine function is a ratio of sides, and the output is an angle somewhere between 0 and pi. All right. Our last lecture we're going to talk about, or our last video that we're going to do, is we're going to talk about the inverse tangent function.